Hey, what's up everybody? I decided to do a video response to some of the topics that Audioholic brought up in my video on multiple batteries part 2, and kind of give you guys my methodology for fusing a system. That way you'll have two methods for actually fusing your system, the way that Audioholic chooses to do it and the way that I do it. Okay, so I'm going to describe to you the way that I do it. I basically use Ohm's law and circuit analysis to find out the current in each leg of the system and then fuse accordingly. So let's go ahead and go over that. So first thing we'll do, let's draw the outline of a car here. For this case, I'm going to use my car as the example. I have 3 batteries in my car, 2 up front, 1 in the back, and my amplifier in the back. Okay, and let's go ahead and plus and minus here. Okay, so let's go ahead and draw the equivalent circuit of what we're looking at here. That's going to be 3 batteries in parallel. Let's draw this a little bigger. Okay, so and let's go ahead and label these batteries. We'll call this one B1, B2, and B3. Same thing over here, B1, B2, B3. Okay, and this will be our load. Okay, and you'll notice that I don't have the alternator in this situation because the alternator would be another current source, and what you want to fuse for worst case scenario. So you want to fuse for when you don't have another current source or another source of power sharing the load. So this is the worst case scenario. This is when your current will be the worst, when your alternator is not helping out the system. Okay, so let's go ahead and draw in our power wire. I'll draw the power wires of different colors to make it easier for us to see. So let's say the wire that we put between battery 1 and battery 2 is blue. So we'll just draw it here as blue wire here. Okay? And we'll also draw it as blue on our circuit diagram here. Okay? Between B2 and B3, let's say we're going to use a green wire. Okay, and our wire that actually goes out to our amplifier. Whoops. Let me draw my green wire here on the circuit also. Red wire here. That actually goes out to our amp. So now we have our 3 cables and our 3 cables in our circuit diagram here. I will draw the return wire as black just so that the drawing doesn't become so confusing. Okay, and I won't even draw the grounds over here, but I'm going to show you something about grounds in a second. Okay, now first thing we need to do is determine the actual load on this system. So the way we do that is look at the amplifiers that we have back here drawing current. And we're using my particular example, so I have 2 amplifiers that draw 150 amps each. I have an amplifier back there that draws 50 amps. Add that together and that's 350. So I know at the back of my car I have a 350 amp load that I must meet. Okay, so let's now see how much current is in each leg of this circuit. All things being equal, if these are all 12 volt sources and there's no resistance or anything else, the current in each one of these legs will be identical. the way that we make sure that that's identical is using sufficient cable to carry the current so we don't have any losses due to heat. So what we can do to find out the current in each one of these legs is take our total load that we must meet, and it will be divided evenly amongst these three batteries. So what we're going to have is 3 into 350. And that's going to be 100, around 116 amps. So I know that in each leg of this circuit, I have 116 amps flowing through it. Okay, now that I know this information, I can determine exactly how much current is flowing through each one of those wires. So let's take a look. This 116 amps here is going to flow into this leg right here, and that'll be the current flowing through the blue wire when I've got everything turned all the way up, 116 amps. When you get to this point, these two currents add together. So in this branch, I'm going to have 232 amps flowing through the green wire. This point, these two will join up together, and I'm going to have 350 amps flowing through this network. The reason these numbers don't add up perfectly is because we rounded here. This would be 116 point something down there. So now, as this current 150 amps flows through here, it's also going to come back on the return path. Let me get these numbers out of the way. So you're going to have 350 amps coming back here. At this point, 116 amps will peel off. You'll go back down to 232. Another 116 will peel off, 116. That's why people tell you that the ground cable that you use should be identical to the positive wire that you use, because when it comes back around here, that wire has the same amount of current flowing through it. And if you use a little cheap wire on your ground, or you neglect your ground cable, you're just going to have a big problem. So you should use the same cable. So whatever this blue wire is, the ground wire should be the same. Whatever this green wire, the ground wire should be the same. And if you're using a chassis of your car as your ground, you need to do a big 3 upgrade if you have a high power system in the back. Okay, so what have we learned? 16 amps in the blue wire. In the green wire here, we're going to have 232 amps flowing through it. The red wire will have 350 amps flowing through it if we have our system turned all the way up. So this is how I choose to fuse the network. I look at this. If you look under the hood of my car, you're going to see that there's a fuse somewhere around 116 amps. I chose to do 150 amps because there are surges sometimes in car audio. This one right here, that's 232 amps. This one, if you look under there, you're probably going to see a 250 or a 300 amp fuse on both sides of that. And then this is going to go into a distribution block, and then each amp is going to be fused individually. But this is how I choose to do it using circuit analysis. Now, Audioholic chooses to fuse his networks based on the capacity of this cable, and that's fine. I'll show you the reason I choose not to do that. Under the hood of my car, between the first two batteries, I have a 1/0 cable. That's capable of drawing somewhere around 300 amps. I wouldn't want to wait until 300 amps started flowing through this wire before the fuse blows. I want to know that there's a problem at around 150 amps, because if I wait to 300 amps before the fuse blows, whatever is having a problem is just exposed to more damage. So I want to fuse based on how much current should be flowing through that wire, not how much current can flow through that wire. Same with this one. I have 4/0 cable flowing to the back, and you know, it can take 400, 500 amps flowing through it, and I wouldn't want to fuse this at 500 amps, because if over 250, 260 amps start flowing through here, something's wrong, and I don't want to wait. I want it to blow right then, not when it's too late. So that's why I choose to fuse not based on the capacity of the cable, but based on how much current should be flowing through that cable at any given time. And that's pretty much how I choose to fuse my networks. That's it.